In this lecture, I am going to talk about the logical operators. There are three logical operators in Python. They are AND, OR, NOT. The AND is like just very similar to how we use AND in English. It returns true if both operands are true. A and B. It returns true if both A and B are true, false otherwise. This table here is called truth table. This table shows you how the logical operator work based on the two operands. And for Python, the logical AND spell AND, lowercase. And the logical OR in Python is OR. It returns true if either operand, either A or B, is true. False otherwise. So A or B, only time is false when both A and B are false. And finally, NOT, which is the complement in Boolean. True if the operand is false, false if the operand is true. Basic complement means because this only have a two value complement, you can think of like the opposite. Complement of true is false, complement of false is true. And to write not 8, we actually literally write not NOT A with a space in between, of course. If both A and B are Boolean value, then was A equal to B, this actually is an equality mutual implication. Um, this basically is like exclusive NOR. It's true when both operands are the same. As you can see here, this output is true even though both inputs are false. But A equal to B only saying if both operands are the same. And in this case, both operands are the same, so the output is true. And A not equal to B is like an exclusive OR, and it basically say when the both operands are not the same. This is true if A and B are Boolean value. So assuming P is true and Q is false, P or Q will give you true. P and Q will be false because I have true and false, which is false. Not P, not true would be false. P not equal to Q, that's true because they are not the same. The precedent rules, now that we learn about the logical and relational operator, and we have learned the arithmetic operator before, these are the precedent rules in Python. The highest one are the parentheses, the exponential, multiplication and division, addition and subtraction, relational, logical not, logical and the logical or. These are going from the highest to lowest. For example, this expression is same as this with the parentheses showing because the addition have a higher precedent than the relational operator. A and B or C, the AND, it would do A and B first and then OR with C. A and not B or C, the not B will happen first, and then the result will end with the A, and then the result will be OR with the C. Make sure you understand the precedent rules when you evaluate an expression. And conversely, we must write if an OR coming first, P or Q, if you want to do this first, you have to put parentheses around it. The relational operator have higher precedence than the logical operator. As a result, you will have to use parentheses to denote you want to do the logical operator first. Without a parenthesis, everyone, it would do D not equal to E first. Take a look closely to the precedent rule over here to understand the order of operation. So let's try it out here. True or false, what would that be? Well, it should be true. True and not false? Well, it would be true also. Why? Not false would be true. True and true is true. True or false and false? Because this false and false would be false. True or false is true. True and false or false? Well, true and false will happen first, which is false. False or false is false. 10 greater than 33, false. Or math 101 in string greater than com 101, this is true actually. So false or true is true. 32 mod 4 equal to 0, that is true. And 2 times 4 greater than 20, 2 times 4 is 8. 8 greater than 20, false. True and false is false. 32 mod 4 equal to 0. 32 divided by 4 equal to 0. Integer division, 32 divided by 4 is 8. So this is false. False or 2 times 4 greater than 20, 8 greater than 20, false or false is false. Take a look to see if you got the same answer. Write a Boolean expression to test whether variable num is between 1 and 100 inclusive. So I have a num. I have a variable num. I want to know whether this num is between 1 and 100. Mathematically, you might be writing this way. In Python, in many programming languages, for that matter, you will want to write 1 less than equal to num and num is less than equal to 100. Do not write this. I think a lot of times students write this 1 less than equal to num and 100. Remember what I said before? Anything non-zero is true. This would be true statement. Write a Boolean expression to test whether variable num is 4, 7, or 10. I think a lot of times students write this num equal to 4 or 7 or 10. What's wrong with that? Well, again, anything non-zero is true. So this is true, this is true, as far as Python concerned. So this statement will be always evolving to true. You have to say what you mean because Python doesn't read your mind. So you have to say num equal to 4 or num equal to 7 or num equal to 10. This is a Boolean expression. Do not write this way. Now, I want to say one thing. Going back to the previous example, this actually is a valid Python expression, and you would do what you learned in high school algebra. But this work in Python, it doesn't work in many other language. So I like to do this way, just just so um, when you transition to other language, um, this will also work. But in Python, this expression actually does work, and only in Python.